Hello guys, myself Swapnil Sir and I'm your favorite mathematics teacher and I'm welcoming you all back to yet another video. Already we have started lecture series based on the different topic from mathematics. As the SPI exam is coming closer, so we felt that we have to go for more and more questions. So already I have uploaded plenty of the videos based on all the topics. So if you are interested to see this video, do check in my playlist. So in my today's video, I'm gonna explain to you all one of the very much important topic, which is the probability from your 9-10 syllabus, which is important for your upcoming SPI exam. Based on the probability, you will get the 4 to 5 question, at least 4 to 5 question. As I found in my another question papers, there are near about 7 to 8 questions are there in your question paper. Okay, based on the only probability, and in the probability, in entire complete probability chapter, you have to understand only some sort of a fixed concept. Then you are able to answer all the questions here. Okay, so without further ado, let's get dive into our today's lecture. First of all, we're going to understand some basic concept, and then at the end we move for some of the important examples. So let's get dive into our today's lecture. Our lecture, it is based on the probability. Okay, so already plenty of the videos are there. So this one is a 10th number lecture, which is based on the probability. Okay, yes. So let's start the probability. What actually mean by the probability? Okay, the meaning of a probability, what we have likely outcome possible from our given events. Okay, what is the meaning of a probability? Understand it first. Once you come to understand what we are going to learn inside probability, then next further part, it is quite easier. Okay, what actually meaning of a probability? We have to find out the likely outcomes for our favorable events from the sample space. Okay, and the probability of any event which lies between 0 and 1. Okay, the probability of any event which start from 0 and end it to the 1. That means when we get 1 as the probability, that means our event, it is a successful. Okay, 1 as the probability, then we say that our event, it is a completely successful. And when it is coming 0 as a probability, then we consider our probability, it is a failure. Okay, so it is a failure, chances are there to likely outcomes. And if we get the outcomes between 0 and 1, if you get the outcome between 0 and 1, then we say that the probability occurrence as per their values. Okay, that means if we get the probability like 1 by 10, 1 by 20, 1 by 30, then we decide how possibly events likely to occur. Okay, these things you all have to understand in this our chapter. Okay, in our entire chapter, we just have to find out the probability. Okay, and as per the my observation from previous year question paper, I found that the question based on the dice, coin, and a deck, these 3 questions are very much important. I found most of the question based on these only. Okay, where from the question mostly coming in your SPI exam, first it comes from dice. It is a dice. Okay, yes. Next, a deck. Okay, I hope you all have seen the deck. Okay, card of a deck, most of you all have played that deck also. Okay, so don't take it a negative meaning here, because as the part of a probability, we have to understand what actually meaning of a deck. Okay, that we have to understand what are the likely probable outcomes. Okay, these things develop our thinking power. Okay, why we learning these probabilities? It will be helpful for your mind IQ, or it can develop your thinking power. So that's why you have to understand all these concepts. Okay, what are the possible chances that you can or your mind can think? Okay, for this we have to understand all these concepts here. Okay, first it goes for the deck. Second, first it goes for the dice. Second, it goes for the deck. Third, it goes for coin. Okay, third, it goes for the coin. Okay, so there are plenty another examples are there that you can take as your regular livelihood examples, like you can consider 3 students, 4 girls, like an entire class. This way you can consider for your consider this example for your probability. But as per my observation, we have to be familiar with the dice, deck, coin. Okay, this type of the probable events. Okay. Okay, let's go for the understanding what are these events are. Okay, what actually these events are. Okay. Okay, let me explain first of all dice here. Okay, completely dice. Okay, because we have to understand sample space, random event, okay, favorable event, all these concepts we have to understand. So I'm gonna explain to you all first of all these concepts here. Then at the end we go for understanding the meaning of these definitions. Okay, meaning of these terms from probability. Okay, majorly you have to understand the sample space of favorable outcomes and a sample space or sample space favorable outcome, random event, and all these type of the condition you all have to understand, like experiment and all these things from probability. Okay, I don't think so it is anything difficult here. So maybe you will get the question based on the dice. What happen if you throw one dice? Okay, what happen if you throw one dice with the condition that 6 coming, it is the topmost phase. Okay, 6 coming, it is the topmost phase. First of all, you have to understand the question first, understand it, and then go for the finding possible outcomes from your given example. Okay, now dice, let me explain what we have dice here. Dice, it is like a square based shape. Okay, it is a solid shape that is having total 6 sides. Okay, 6 sides. Every side of the dice contain one number. If you take one side, it goes for 1, second 2, 3, 4, 5 and 6. All numbers are given in the all rounded round side or complete surface side of this dice. Okay, that means you will get the dice like this. Okay, let me draw the dice as it look like this way. Okay, now see that every face of the dice, it is having different numbers. Okay, all are the different number. One dice, it is having 1 dot, another side it is having 2 dot, third side 3 dot, fourth side 4 dot, 5 dot, 6 dot, and all the sides contain these many number of dots. Okay, so we have to find out the probable outcomes. Okay, what happen if we throw single dice? If we throw single dice, we have possible chances to get only at once. Okay, topmost phase, if you consider, you will get the at a time one number. Okay, or number of dots are coming for our topmost phase, it is like 1 2 3, but at the time we will get only one. Okay, yes, it is only for a single dice. Okay, in most of the case I found in your example. Okay, there are at a time they thrown 3 dice, 2 dice. Okay, that time we have to think how can the probable outcomes are there. Okay, so here I thrown single dice first. Okay, I thrown single dice. Then secondly, we go for throwing 2 dice. Okay, we go for throwing through 2 dice. This one is first, this one it is the second dice. Okay, yes, this one is the first dice, this one is the when we throw 2 dice at a time, then we have to think what are the probable outcomes are there. Okay, and when we have 2 dice, then that time we have to write that outcomes in the form of order pair. Okay, that means if I write in the form of order pair, first number it goes for the outcome from our first dice, and second number it goes from the outcome of a second dice. Okay, if it goes for the 3 dice, that means you have to think about we have order pair in the form of 3 dice. Okay, first, second and 3. Okay, this is the way that we can write a total outcome or favorable event from our dice. Okay, now let me explain what is the favorable event here. Okay, what is the favorable event in the case of all these dice, deck, coin. Okay, yes, what about for dice favorable event? That means we have some operations. Okay, we have to find out what are the possible chances, likely outcome that topmost phase gives number 4. Okay, this one we consider it as the favorable outcomes. Okay, favorable outcomes, and total entire number of event we have here in our dice. That means total number of 6 chances, like first time 1, second time 2, third time 3, fourth and fifth, and at the end similar like 6. Okay, so when we combine all 6 event, then we consider it as the under sample space. Okay, so easy definition of a sample space, I would like to explain here that the sample space means total entire event which we have in our given outcomes. Okay, so we consider it as the sample space. And what are the major operations we have to follow on our sample space? We consider it as the favorable event. So using favorable event and sample space, we can find out the probability of an event. Okay, so probability of an event, we write, let me write probability of event. Probability of event. Okay, so probability of event, we write total number of a sample space, it as the part of a denominator. Okay, and as the part of a numerator, we write the favorable outcomes from our sample space. Okay, favorable outcome and a total divided by number of outcome from sample space. Okay, total number of outcome from a sample space. This one is the standard formula which is very much important for your SPI exam. Mark it very much important. Okay, for finding every probability you have to deal this formula. Okay, the formula, it says that probability of any event, we write it as the favorable outcome which possible from our given event and total number of a sample space. Okay, total number of a sample space, all the outcomes coming from our sample space, we write it as the total outcome from our sample space. On total, it is complete their division, we consider it as the probability of a event. And always remember that the probability of event, it start from 0 and end it to the 1. Okay, so probability of any event, I consider event E, which lies between 0 and 1. Okay, the probability of any event which lies between 0 and 1. Okay, it cannot exceed than 1 and it cannot be a negative. Okay, always remember. So I explained here most of the concept here. Okay, and experiment means, the definition of experiment means here we have to find out the probability for some certain events. We consider all these operation as a experiment only. Okay, so that's it here. Now, as I explained some of the terminology from probability, we have to be familiar with all of them. Okay, yes. So I feel that we have to solve some of the example, but before solving some example, we left here with a two operation, like I already explained for the dice. Second, it left for the coin and deck. Okay, let me explain first of all coin, deck, and then at the end we go for solving some of the example. I didn't included more example here, but you have to follow similar example from your textbook. Okay, so as we have limited amount of time, so what we do so far? Okay, what we do here, that we go for understanding concept first, and at the end we solve little bit example. Your remaining task is that you have to attempt this example by yourself, find out the more example from your textbook book and solve these questions. Okay, and I will put some of the questions in our description box. You can find it out there from PDF. Okay, yes. Now next part, it is here as the deck and coin. Okay, what happen if we use a deck card of a deck? Okay, deck of card. So we know that a deck which contain 52 cards. Okay, deck it is having 52 cards. It divided by 4 different part. Okay, 4 different part. Diamond, okay, spread, okay, this type of we have 4 different cards. Total number of cards in our deck, which is of 52 cards. They contain total 52 cards. Okay, 52 cards which is divided into the 4 set. Okay, 13 4s are, yes, okay, so which are all are divided into the 13 set. Okay, so 13, again 13, and again 13. Yes, 13 that means 13 4s are 52. There are, we have total number of 52 cards, and all are divided into the fourth set as a 13. Okay, yes, and each set contain first ace from second number 2 to number 10. Okay, then jack, king, queen. Okay, ace to 10, then jack, king, and queen. Okay, these many amount of the cards we have in a 13 set of the 13 set of our deck. Okay, now see that we have 52 cards. We divided 52 cards into the 4 different set, 13. Okay, and 13 set of a card which contain first ace, second 2, 3 up to 10, then jack, king, and queen. Okay, so these things we have important here about the deck. Okay, if you get the question based on the deck, you have to understand what actually inside the deck. Okay, most of you all have seen already the deck. Okay, but so many students, they are little unfamiliar with the concept of the deck, that you all have to understand these conditions here. Okay, yes, that's it for the deck. Let me go for the next condition, which is next operation, sample space as a coin. Okay, what actually coin operations are here. Okay, in our probability. Okay, coin operation, it says that we have to toss a coin. Okay, we have to toss a coin here. Once we toss a coin, we have to find out what are the likely outcomes are possible, what are the probability are possible using some or 1 or 2 coins or some random operations. Okay, yes, when we toss a coin, let me consider one coin first. Okay, let me consider one coin. Let me consider one coin first. Yes, we'll go for only one coin at the beginning, then we add another second coin, third coin, and then we see what are the possible outcomes are there. Okay, yes, if I toss a single coin, tell me how many outcomes are there? Only 2 outcomes. Okay, whether it is a tail or whether it is the head. Okay, tail means tail, T-A-I-L. Okay, yes, not a T-A-L-E. Okay, we have 2 outcomes when we toss a coin. One it is the tail and another one it is the head. Okay, and we have to decide what are the major possible outcomes from here. Okay, we have possible head and second. Okay, we have these 2 outcomes possible. Okay, if we toss a coin, we get whether head or tail. So possible operations we are getting here, head and tail. Okay, what happen if I add one more coin? Then that means if I toss 2 coin at a time, then what are the probable outcomes we have here? Let me write for 2 coins. Okay, if I add 2 coin, it is a possible then first time we get the head, second coin it get the tail. Okay, both coin are possible to give us a head. Okay, both coins are having possible chances head. Second coin having possible chances tail, head, and tail. Now see that if we toss a 2 coin, okay, we got the possible outcomes 2 raised to n, okay, that means 2 raised to 2 possible outcomes we have here. 2 raised to n as a 2 raised to 2, that means 4, okay. Now see that, count all the outcomes we have, total number of outcomes we have 4 here, okay. So when we toss a 2 coin, we get the 4 outcomes. When we toss a 3 coin, how many outcomes are possible? Let me know in my comment section, okay. So tell me how many outcomes are possible when we toss 3 coins, okay. And we have a formula for finding the nth number of tosses, okay. So when we have n number of tosses, then we write 2 raised to n, okay. That you need to know, okay. Yes, this one is our about the coin, everything about the coin, okay. Yes, I hope you all have understood about the deck, dice, coin, and there are some another operations too, but we're gonna see all these operation in the form of examples, okay. To directly go for each and everything, it is quite bit difficult, but as we solve more and more example, we come to understand it, okay. So let's get dive into our today's example part, okay. All are the very much important for your upcoming SPI exams, so don't forget to solve similar example by your own, okay. That I can guide you what you have to do, but you have to follow actually what you need to do, okay. Yes, now let's go for some example. First of all, we're gonna see some examples here. That your task is that you have to add some example by yourself and go for solving the questions, okay. Yes, already I explained here, okay. Yes, I added 2 or 3 to 4 question. My first question, it says that a dice is thrown once, okay. That means we have given a dice, it is thrown at once, remember that a dice, it is thrown at once. Then let me write the probable outcomes, okay. A dice is thrown at once. A dice is thrown at once, okay. A dice is thrown at once. We know that what are the probable outcomes we have here. Whether at the topmost space it gives 1, okay, 0 it is not there, it gives 1, it gives a 2, it gives 2, after 3, after 4, after 5, after 6. Is there any another possible chances that it is possible here when we throw dice? No, it is only the possible chances we have here. We can get 1 to 6 number of outcomes here in the top face of our dice, okay. Yes, okay. Then total number of outcomes in our sample space. Now see that this one is our complete sample space, okay. What we have here? Complete sample space, okay. This one is our complete sample space. Consider this one as yes. And the number of element in our sample space, we have total number of element, which is 6 here, okay. Total number of element we have given 6. That means complete element in our sample space here, okay. Total number of element in 6 here, it is 6, okay. And we have to find out the probability of getting a number greater than 4, okay. That means we have given favorable outcomes, that it says that we want the number greater than 4, okay. Greater than 4 means 4, it is not the part here for our favorable outcome, okay. Greater than 4 means the number which is a bigger than 4 but not 4, okay, which available in our sample space, okay, which available in our sample space. Now let me write a favorable outcome. Favorable outcomes, okay. Consider set E, okay. So number of element in a set E we have here. Number of element in a set E. Now let me ask you one thing, which are the number which is greater than 4, okay, but not 4, which available in our sample space, which is of 5 and 6, okay. Then number of element in our sample space here, which is a favorable element here, 5 is 6, and number of element in a E, which is a 2. Okay, number of element in our given favorable event is a 2. Okay, and what we have to find it here? We have to find out what is the probability for our favorable event. Okay, so probability of a favorable event, we say that probability of a favorable event which is equal to number of favorable event divided by number of element in our sample space. Okay, yes, so probability of our favorable event E can be written as number of element in our set E divided by number of element in our sample space E's. How many numbers we have here? Set E 2 and number of element in a sample space which is a 6. Okay, yes, then 2 by 6 we write 1 by 3. So 1 by 3 which is our correct answer here. Okay, 1 by 3 which is our correct answer. I hope you all have understood this solution. It's nothing, it is difficult here. Okay, yes, let me go for the next question. Okay, let me go for next question, just a minute. Yes, let me go for next question. First, I explained here. Okay, in my next question, we have given a card with a number 22101. Okay, what we have given card? We have given card with a number 22101. Number 22101. Okay, we have card with a number 22101 are placed in box. Okay, what we have done? We have to placed in a box. Okay, a card 22101, the number which start from 2 to 101, which are the placed in a blocks. Okay, that means 2, 3, 4 and so on to up to 101. Okay, all these numbers are placed in a box. Okay, yes, a card is selected randomly from the box. Okay, so we have card and the face of a card which is written to 101 different numbers. Okay, on a different cards. So we have to find out a card is selected from a random from box. Okay, and the find is the probability that card which is selected has a number is a perfect square. That means what we have favorable outcome given here, we have to find out the favorable outcome that the card has to be a perfect square number. Okay, perfect square number, but these numbers need to be a between 2 to 101. Okay, now let's find out the number which between 2 to 101. Okay, 2 to 101, there are total 100 number of the cards. Okay, yes, how many cards are there? Total we have 100 number of cards. That means number of element in our sample space, number of in our sample space, that is n of s. What we have n of s, which is 100 number of elements we have here. Okay, how many number of elements we have here? 100 number of elements, which is the between 2 to 101. Okay, you may count the number from 2 to 101, you will get the 100. Okay, or you may guess the number 2 to 101 means 1 to 100. That means total number of element is 100 here. Okay, yes. So I got the number of element in our complete sample space. Now I have to find out the number of element which is from favorable outcome. Okay, yes. Number of element in a favorable outcome, and favorable outcome, it says that we want the number between 1 to 2 to 100, and these need to be a perfect square. Okay, yes. Let me write the perfect favorable outcome. Consider number of element in a E or set E. Okay, E set contain perfect square number 4, after that 9, after that 16, 25. Okay, after that 49, after that 64. Okay, after that 49. Okay, 64. What we have more? 49, 64, 81 and 100. Okay, 81 and 100. These are the perfect square. If you're going to take their square root, you will get the perfect square number. Okay. Yes. Now let's count out how many numbers are there. 1, 2, 3, 4, 5, 6, 7, 8. Okay. One more number it is remaining. 25, 49, 64, 81, 100, 4, 9, 16, 25, 36 is 36 also remaining. Okay. Yes. Total this number we have between 1 to 100, which are the total number we have here, number of element in our favorable event, which is a 9. Okay. And we have to find out what is the possible likely outcome or probability we have here that given number which is a perfect square. Okay. So probability of our favorable event E, we write 9 divided by number of element in our sample space. Okay. So 9 divided by 100, which is our probability of event, which is given in our option C here. Okay. Now see that one thing you may have observed here, that all the probability for our likely event which are coming, and they are between 0 and 1. 9 divided by 100. That means if a denominator is a bigger, then the number is a smaller. Okay. Denominator is a bigger, then number goes smaller. Okay. Always remember. Yes. Let's go for the next question. A card drawn from a well shuffled deck of 52 cards. Okay. Now let me write the sample space here. Okay. Total number of element in our sample space. Number of element in a sample space. Okay. So number of element in a years we have here. What we have here, a card, okay, drawn from a shuffled deck of 52 cards. That means a deck of a card we do have here, and they are well shuffled. Okay, they are well shuffled, and we know that total number of cards which present in our deck, which is our total 52. Okay, yes, total number of card we have here 52. Okay, and we have to find out the probability of getting ace. Okay, probability of getting ace in our 52 cards. Okay, yes, probability of getting yes. Okay, so number of element in our favorable event. Okay, so consider favorable event. Okay, number of element in E. Okay, number of element E, consider it as we have total number of 52 cards. So sample space gives us the 52 number. Okay, and the getting ace. Okay, number of element E, we have favorable sample space already there. Okay, favorable event we have getting ace. We know that in a complete entire 52 card we have number of 4 aces. Okay, so number of probability of event, probability of our favorable event that getting ace. Okay, okay, which is a number of element in our favorable event divided number of element in a sample space. Okay, so 4 divided by 52. Okay, so 4 divided by 52, that means 1 divided by 13, which is a correct answer. Okay, that's it. That's it for our today's examples. Okay, I added these many examples. Yes, and next question also I added one more. Sum of a probability of elementary events. Always remember that when we are going to add all the probability at once, we will get their addition as only one. Okay. Yes, the probability for all the events which we have in our sample space always gives us the value 1. Okay, always remember. And the failure for our event, it gives us 0. Okay, or probability of event A plus probability of event A complement, which is equal to always 1. Remember these important formulas. Okay, so we have here elementary event probability of addition for all elementary event, which is a 1 here. Okay, yes, that's it for our today's lecture. I'm expecting that you all have understood everything from my today's lecture. If you found anything difficult, let me know in my comment section. Okay, so in my today's example, I begin my lecture with some of the important topic from the probability that I explained with some of the example like a dice. After that coin, after that deck, I explained some sample space, random event, after that favorable event, all the concept I explained here in my today's lecture. Some of the important remark also I explained it here, some examples I solved it here. Okay, I hope you all have understood everything. So if you wanted to solve similar example, you can check it from your textbook. I will come up the similar videos like this one, okay? So if you found everything helpful here from my today's lecture, let me know in my comment section. So thank you everyone. Thank you for my today's lecture.